Okay, talking about the power rule. So looking at power of a power here in that column on our table, we have 5 squared in parentheses, and then outside of the parentheses, we are taking that to a cube or to the third power. So notice that we take what's inside of the parentheses and multiply it by itself 3 times. And then we can look at what's inside of that parentheses, which is 5 squared, and we know 5 squared is 5 times 5. So we can multiply that out as 5 times 5 in each one of those. Then we can count our factors of 5. So we have 1, 2, 3, 4, 5, 6. So it becomes the number of factors is 6, and we take the number of factors, we take the base, and that becomes our product as a power. So we have 5 to the 6th power. So let's take a look at the negative 3. So here, it's like we are taking negative 3 squared. Oh, let me rewrite that. That's not looking too good. Okay, we are taking negative 3 squared times negative 3 squared. So we are squaring that, which is multiplying it twice, but also keeping what's inside of those brackets, negative 3 squared. So then again, if we think of this, we know what negative 3 squared is, which is going to be negative 3. Again, I'm going to rewrite this because this is sloppy. So this is negative 3 times negative 3 times, again, negative 3 multiplied by a negative 3. So our number of factors, we have 4 of the negative 3's, and it ends up being, I'm sorry, I am reading this and it looks funny. I don't know why they have that. We missed something. So it ends up being negative 3 to the 4th. Okay, let's look at the one underneath. So we have b squared to the 4th power. So I'm going to take b squared and multiply it by itself 4 times. And then I'm actually going to take the b squared and multiply that out, again, still 4 times, but do b times b inside of those so that we can see all the factors that are truly being multiplied together. So then count up your factors. You have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 factors of b. So this ends up being b to the 8th power. So hopefully you can see the shortcut that is happening. And what we're doing is we are multiplying. I spelled that wrong, I'm sorry. Multiplying the original exponents. Which in turn looks like a to the m in parentheses, and we're raising it to another power, which is n. So it ends up being a to the m times n. So this is where you're going to have to learn the distinction between if we are multiplying variables or if we are adding them. Okay, so let's look at some examples down here. So write each expression using each base only once. So we are looking at n to the 4th, but we are raising that to the 7th power. So this becomes n to the 4th times 7. So we have n to the 28th power. So let's look at letter B. We have x to the 3rd power raised to the 5th. So this ends up being x to the 3rd times 5. Negative 3rd, excuse me. So it ends up being x to the negative 15th power. But remember, math etiquette, we never leave a negative. So this becomes 1 over x to the positive 15th power. All right. Let's look at example 2. So we have simplify y cubed times the quantity y to the 5th, and that is raised to the negative 2nd power. So think of y cubed. This is like your coefficient that's on the outside. We're eventually going to multiply it in, but we don't want to bring it in yet. So we just have y cubed times this information that is going on here. Y to the 5th raised to the -2 power. So then we do what's inside those brackets first. So we still have y cubed, but now we're going to have, we take 5, multiply it by -2, ends up being -10. And now this is where we need to look at the exponents, because we aren't going to be multiplying these exponents, we add these exponents together. So this becomes y to the -7th power. And again, math etiquette, we never leave a negative, so it becomes 1 over y to the +7th power. So now we have 3 examples down at the bottom, and then now it's your turn, and we're going to be doing the same thing. Let me switch colors. So think of this as x squared is being multiplied, and then we put all of this information in brackets so that we remember to do it first. So we have x squared times. Now we look at everything inside the brackets. So we do 6 times -4. So then we end up having x to the -24th power. And now we can go back through and we can add the exponents down here. So we have 2 plus 24 is going to give us x to the -22nd power, and we never leave a negative, so that's going to become 1 over x to the 22nd power. Now let's look at letter B. So we have, again, w to the -2nd. We're going to think of that as like a coefficient in front that's being multiplied into the parentheses, but we're not ready for that yet. We need to do the exponent that's on the outside over here. So by putting that in brackets, we're able to see that as the first step that we're supposed to do. So I have y to the -2 times, we do 7 times 3, which I said y, it's w. We do 7 times 3, which is 21. So now we add our exponents together. So this becomes -2 plus 21, and we end up with w to the 19th power. All right, and last one on this page. So now we need to look at where everything is put. Everything is just reversed. Down here, that r cubed is like what is on the outside, what's first that we did beforehand. So that's like our coefficient. So we keep the r cubed, but everything else goes into brackets. So we have r to the -5th taken to the -2nd power, and this becomes r to the +10 power, and we add our exponents together. So it ends up being r to the 13th power. All right, now we are going to flip over to the back and look at this in a little bit separate way. So on the inside of those parentheses, remember, just because there's not a dot or a multiplication symbol doesn't mean that those numbers are just stuck together. They're actually being multiplied together. So the 4m is actually 4 times m. So we have that whole quantity being cubed. Sorry if that went off. I don't know how to make it go away. So we're just going to leave it for now until it goes on its own. So we're going to take what's inside, again, and multiply that by itself 3 times. So we have 4m times 4m times 4m. And then we can look at each one of those terms as separate terms. So 4 is its own separate term. It's being multiplied by itself 3 times. And so is m its own separate term. They're different bases being multiplied by itself 3 times. So then we get 4 cubed times m cubed, and we simplify out the 4 cubed, which gives us 64, leave m cubed as it is, and that's our answer. So if we look at ab to the 4th, we're going to have ab times ab times ab, and one more time. So then we look at each term as its separate section, or separate, not section, each variable as its own separate term. So think of the a's that you have. So this ends up being, you have a times a times a times a. which is going to be multiplied by b, 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 and b. So you end up having b times b times b times b. Sorry, I know everything is running over. So then what we would write in this box, we have how many a's? 4 a's, so it ends up being a to the 4th. And same for the b's, b to the 4th. I don't know why I wrote that like that. A to the 4th, b to the 4th. And that actually ends up being the same answer in both of these boxes. We don't have anything we need to simplify out. So the last one that we have, I'm going to write it below the box. Well, actually, I might have room. So we have everything on the inside being multiplied by itself. And then we look at everything as separate things. So I have 3 times 3. So they all become separate terms. X and X. You are trying to essentially combine like terms. And then I have Y and Y. So we have 3 squared, X squared, and Y squared. And then our final product, we have to simplify out 3 squared, which is 9. X squared and Y squared stay the same. So hopefully you see the shortcut. And what we are doing is we just distribute the exponent to each piece, or as I've been saying, term, in the parentheses. So just how it is below. Everything is on the inside. We have a times b to the nth power, and it ends up being as if we've taken this n, distribute it here, and then distribute it here, and we get an times bn. And that's what we're going to do with these last few examples here. I'm going to keep that up. So we're simplifying n to the 5th squared times 4mn to the negative 2 cubed. So we are going to distribute what is on the outside first. So bring that 2 inside to the first parentheses, and it becomes n to the 10th power. And then we're multiplying, and we're going to bring this 3 on the inside, distribute it. Ends up being 4 cubed, m cubed, n to the negative 6 power. And now we go through and combine like terms. So look at the ends. We're going to have, we still have that 4 cubed, m cubed, and then 10 plus negative 6 is going to give you n to the 4th power. Now we go through and simplify that 4 cubed, which ends up being 64 m cubed n to the 4th. So let's do that again just a few more times. So we look at this exponent and we distribute. Remember when we first did PEMDAS or order of operations, when we saw parentheses, we stopped. We knew we more than likely had to do something. If there wasn't anything going on inside, we needed to look outside because we could have possibly needed to distribute something inside. That's what we're doing here. We're distributing that, but we're multiplying the exponents. So x to the negative 2 times 2 gives you negative 4. And then we're going to do the same thing over here. Distribute the 4 on the inside. So this becomes 3 to the 4th power, x to the 4th power, y to the 20th power. Now go back and combine like terms. So we have 3 to the 4th power, and then negative 4 plus 4 is 0. Anything to the 0 power is 1, so we don't need to worry about that. But we can drop down that y to the 20th power. And then we need to we need to, let me turn that off. We need to simplify. Lost my train of thought. And 3 to the 4th power is 81. Then we have y to the 20th power. All right, let's move on to letter B and letter C. So letter B, the first one, let's distribute that 3 on the inside to everything. So that ends up being 6 to the third power, A to the third power, B to the third power. And then let's distribute that 2. So we have 5 squared times A to the negative 6th. Now we kind of get our like terms together. So we have the constants. So we're going to write out 6 cubed times 5 squared. And then we have A's. We need to add those together. A cubed times A to the negative 6. So 3 plus negative 6 gives you A to the negative 3. And then last thing that we have, I don't even need to really underline it, but we have B cubed. So now we go back and we combine everything. So 6 to the third power is 216 times 5 to the second power is 25. We still have that, excuse me, I'm writing things funny. We still have that A to the negative 3 and that B to the third power. So then we need to multiply 216 and 25, and you're going to get 5,400. And we look at the A, it's negative, so we immediately know it needs to be moved down. And then B can stay up at the top, it's positive. And that becomes our answer. All right, last one that we have to do. We have distributing the 4, so it ends up being 3 to the 4th times C to the 20th. And then we need to distribute the 3. It becomes C to the 6th. Go back, combine like terms, C's. So we have 3 to the 4th power times C to the 26th because we add. And then we go back and simplify 3 to the 4th, which we know is 81. And then C to the 26th stays up top as well.